Hello and welcome to today's video. In this video, I'm going to go over 4 practice problems. To watch today's video, you need to know about for loop, while loop, conditions and branches, and file handling. Link to those videos are available in the description. The first problem, as you can see on the screen, is write a program, derivative.c, to approximate the derivative of e to the power of x, cosine of x, sine of x, at x equal to 0 using the limits. And the equation, as you can see, is provided on the screen. Your program should use values of h equal to half, 1 over 4, 1 over 8, and goes on, which is basically 1 over 2 to the power of n, where n is read from the keyboard as shown here. So the sample input is enter n for h equal to 1 over 2 down to 1 over 2 to the power of n, and the user will enter, for example, 20. Means that they wanted to go from 1 over 2 to 1 over of 2 to the power of 20. Your program output should be written to a file. So this time that we are using file handling, you're going to open the derivative out.txt for writing, and the output should look like what you can see in the screen. We basically wanted a table that the first row is h, the second row is derivative of the exponential, and it goes on. And if the user wants 20 rows, then basically if the user entered 20, means that we want to print 20 rows. I'll start by include stdio.h. As in this question, we wanted to use the exponential function and sine function and cosine function. We better include the master library as well. And I'm just going to create an empty main function. As always, I'm going to divide this into different steps. Step 1 is declare your variables. Step 2 is open file for writing. Step 3 is ask the user to enter n and scan it. Step 4 is to print the first 2 rows of the table to the file. Step 5 is to calculate the derivative and print them to the file. And finally, step 6 is to close the file. So at step 1, I'm going to create my variables. The first variable I'm going to create are h and derivative of the exponential. I'm not going to create derivative of sine and cosine. It should be easy for you guys to add it. I'm going to create 2 integers, increment and n. I'm going to also create a file pointer, because we wanted to write the output of this program to a file. If you don't know what is file pointer, I have a video for it. The link will appear on the screen. I will also put it in the description below. So at this step, I'm going to open the file for writing. To do that, I'm going to use the fopen function. If you don't know about the fopen function, there is a video. The link will appear on the screen. I'll also put the link on the description below. I'm going to do the step 6, which is close the file. So we open the file for writing, and I'm going to close the file here. Now I'm going to go ahead here, and on the Solution Explorer, right click Open Folder in File Explorer, and then you would see my file manager, my Windows file manager here. There is only hello world.c. There is no other file in it. And if I go ahead back to the Visual Studio and press Ctrl F5 to compile and run the code without debugging, you would see that my program runs without any error. I will press enter, so this window will be closed. And as you can see on the file derivative out.txt now appears here. So at line 12, this file will be created on the folder that my project exists. If I take this and drag it to the Visual Studio, you can see that the file is empty. And the reason is because we haven't printed anything in the file yet. Imagine we had this file and there was some text on it. For example, in this case, I can put this is Reza. And now the file, we already have derivative out.txt, and there are some content on it. I'll save it so it will be stored on my disk. And I'll go back to the hello.c here and press Ctrl F5, and the program runs again. If I press enter, and if I go back to the derivative out.txt, you would see that the file is empty. So fopen function with the mode W, which is the write mode, it will delete a file if that exists already in your disk. So if you wanted to print the output to derivative out.txt, and there is already a derivative.txt and derivative out.txt on your disk, it will delete that first and then create a file for you. Step 3 is to ask the user to enter n and scan it. You guys have already done that a lot of times. I'm going to skip that. Step 4 is to print the first 2 rows of the table to the file. What I'm going to do, I'm going to first print them to the screen. I'm going to use printf function and write it the same way as it is on the sample output provided by the question. And I'm going to also put a \n, so we will go to the next line after this command is being printed. The same thing for the next line. I'm going to use printf function. If I press Ctrl F5 to compile and run the code without debugging, you would see that what I need is being printed on the screen, and it's correct. If I press any key, we'll be back to Visual Studio. And I wanted to tell you how to transfer this from being printed to the screen to being printed to the file. So I'm going to copy this and paste it here. So instead of printf function, we're going to use fprintf function. So it only has a character f at the beginning. And then the first argument is the position of the file pointer. So you have to tell the C compiler, where is this blinking cursor? Right now you see my blinking cursor is between the parentheses and open quotation. So I have to tell C, where is this open cursor, that he can start writing on it. Okay, what I would do here, I will provide the file pointer. Okay, now C compiler knows that how to write this to a file. I'm going to comment this line because we don't need it anymore. And do the same thing for the second line of the table. I'm going to also comment this one. And if I press Ctrl F5, I'll press any key to close this window. And then I click on the derivative out.txt here. And as you can see, what we saw on the screen, what was printed on the screen, now is printed to the file. Okay, step 5 is to calculate the derivatives and print them to the file. In this case, I'm only working on exponential function. I'm only calculating the derivative of the exponential function. Okay, I'll come here and write a for loop. In this for loop, I'm going to increment each time that the user wants. For example, if user enters n equal to 20, it means the user wants this to be printed 20 times. You need a for loop. In the for loop, I created the variable increment. I'll set the increment to be at 1 because this variable has to have a start point. And then I'm going to put the condition of the for loop. The condition of the for loop is increment to being less than or equal to n. It means that if the user entered 20, I don't want to go and print 21 line for the user. I'm just going to print 20 lines. And in order to have, because n has to have a value and we haven't done step 3 yet, I'm just going to hard code n equal to 20 for now, but you can put the proper code, printf and scanf, and replace this with n equal to 20 that I put here. This is for just testing our code. And the next step is to increment the iterator, which the variable name is increment right now. So I'm going to say increment plus plus. In the body of the for loop, I'm going to write the code that I wanted to execute each time that this for loop is being run. So the first thing is I want to calculate h equal to 1 over 2 to the power of what the user input 20. So the first time it's 1 over 2, the second time is 1 over 4, the third time is 1 over 8, and goes on. So I can use power function to do this, but I can also benefit this loop. So in order to do this with the power function, I can say h is equal to 1 float number, actually, because h is a float number, divided by power. I can use power function because we included mass library. And in the power function, I'm going to put 2 to the power of increment. Because if we are at the first loop of this for loop, I want increment to be 1. If we are at the 20th loop, I want increment to be 20. I want the user to see how the accuracy will change by increasing n. And on the next line, I'm going to calculate the derivative. So as you know, guys, for loop has 3 different parts. If you don't know about for loop, I have a video for it. I'll put the link in the description below. So we can break this 3 parts of a for loop into 3 different lines. The only reason I'm doing it is I know it doesn't look good. The only reason I'm doing it, I wanted to debug my code and show you guys step by step what is happening when the C compiler reads your code. Okay, and execute your code. So if I go to debug menu and click on start debugging, or just press F5. Oh, we have to actually put the breaking point first. I'm going to put the breaking point at line 24 first. So I'm going to go to debug menu, click on start debugging, or just press F5. And now we're at the debug screen. Okay, so if I step over at this line, what will happen? First, let me show you my local window. These are the variables that I have in this file. So the first variable is derivative exponential, not initialized. We don't want it to be initialized. H is not initialized. Increment is not initialized. And then is 20. We hard-coded that. We know that already. Okay. So by the yellow line pointing at line 24, it means that this line hasn't been executed yet. If I step over this line, I expect the increment here to change the value to 1. And that's exactly what is happening here. So the next is to check to see if my condition is true or not. We know that in for loop, the only way that the body of the for loop would be executed is that the condition should be true. And in this case, 1 is less than or equal to 20, and it's true, and the code will be executed. But I wanted you guys to pause here and guess which line will be executed if I step over line 25. Okay, you guessed it right. If I step over, it will go to the body of the function. We don't want it to increment it at the first loop. At the first loop, this increment plus plus wouldn't be executed. So first, h is going to be calculated. And right now, as you can see, the value of h is undefined. And if I step over, the value of h will be 0.5. And then if I step over line 29, the first derivative will be calculated, as you can see on the screen. So now the interesting point here is if I step over this, actually pause that, try to think about it. If I step over line 30, which line is going to be executed next? You guessed it right. We are going to jump to line 26 because increment, the iterator, has to be incremented by 1. Now the value of variable increment is 1. I'm going to check the value of variable increment against n again to see if if it's true, we should execute the body of the for loop, and if it's not, we shouldn't. And obviously 2 is less than 20, so it is true, and we will execute. And we will continue executing the body of this for loop for 20 times. So I'm going to show you something. This time, the increment would be 20. Still 20 is less than or equal to 20, which the condition is true. The body of the for loop will be executed for the very last time. And if I step over, you would see that increment plus plus. Now, if I execute this, and it's 21. 21 is not less than or equal to 20 anymore. And if I step over, we will be jumping to the next executable line in the code. Let's get out of the debugging menu. And now we need to print at each step, print h and the value of the derivative of h, derivative of an exponential function to the file. So what I'm going to do, in the for loop, I'm going to use fprintf function. At each iteration, I'm going to print a message to the file output. And the message is, so I'm going to print h first, which is a %f, which is a float number. And then I'm going to print exponential, derivative of exponential, which is also a float number, so %f. And then I'm going to provide the arguments, which are h and derivative exponential. And if I press Ctrl F5 to compile and run my code without debugging, and if I go back to the derivative out.txt, oh, okay, we forgot to put \n. That's important to go to the next line each time. Let's press Ctrl F5 again, enter, and now it works. You see that the output is similar to the output provided by the question. So try to add other derivatives to this problem and make it and complete the problem yourself. The other thing that I wanted to quickly mention here is we calculated h each time using a mass function, but we could have leveraged our for loop here as well. Let me actually bring the for loop back into the one line that it had before. Okay, so if I initialized h with 1, then I can come here and say h is equal to h each time divided by 2. If you look at the output I just printed out to my derivative out.txt, it's 0.5, then 0.25, then 0.125, and that's going on. Each time it's being divided by 2. So I can leverage it and remove one step of calculating and make my code more optimized this way. So each time this loop is being run, h will be divided by 2. If we're going to the debug mode and watch what happens to the code, so now h is not initialized. After this, h would be 1. And when we jump into the for loop, the value of h will change to 0.5 because it's being divided by 2. And at the next loop, I want the value to be 0.25. And as you can see, the first line in the body of the for loop is line 27, and it will take care of that action. Practice problem 2 is asking us to write a program sumIt.c that reads an integer n from the keyboard and then sum the integer between 0 and n. Your program should be able to handle both positive and negative values of n and should write the sum to the output file sumitout.txt. Note that your sum should not actually include 0, since that doesn't affect the sum. Your program should open the file sumitout.txt to append. So this time be careful that we are opening the file to append, not to write on it, because if you open file for writing, it will discard any of the file with the same name on the folder and will just delete it and create a new one, and you don't want that. Okay, and the question is asking us to run your program twice with the value of n equal to -10 and n equal to +5. Here are sample, so we have been provided by sample input and output, as you can see on the screen. Okay, with no further ado, let's jump to Visual Studio and see how we can do this. I'm going to divide this question into different steps, as we always do it, and it always helps us to organize our code. Step 1 is to declare the variables. Step 2 is to open the file for appending this time, not writing. Step 3 is ask the user to enter n. And at this step 4, we're going to calculate the sum and print it to the file. And step 5, always when we're dealing with file, the last step is to close the file. To open a file for appending, I'm going to use the, again, fopen function, but so let me write the file pointer. Imagine we have a variable file pointer that the name of the variable is file output. And I'm going to use the fopen function. The same thing here. The first argument is the name of the file that we wanted to open, which is sumit.out.txt. And now the thing that is different than what we did before is the mode is A, which is short for append, rather than W we used to use, which is short for write. What's the difference here? Let me actually create the variable here. So I'm going to create file pointer file output. And let me go ahead and complete step 5 here as well. We know that it's just fclose file output. So if I compile and run my code, as you can see, the code run without any error. If I press any key, the code is being compiled. If I go to Solution Explorer, right click on Hello World and click Open Folder, and I'll be prompted with the folder that contains my project. So if you look here, then there is a new file that's submit.out.txt. The good thing is, if you don't have that file, the modifier A, the mode A, will create the file for you. But if you have it, it won't delete it like what we saw in the write mode. It will only open it and add it to it. Okay, so let me show you what I mean with this. Is if I add a comment here, for example, this is ENGM 1081, and save it. Now, if I run my program again and program runs successfully, if I press enter or any key and then go back here, you see that the file still exists. I mean, it's not like the time that we used mode write. And if you have a fprintf function somewhere, for example, let's put here fprintf, and the first argument we're going to provide is the file pointer, which is file output. Second argument, I just wanted to print a message to the file, 1, 2, 3, 4, and that's it. Control F5 to compile and run without debugging, and the code runs perfect. And if I press enter and we go, you see that 1, 2, 3, 4, 5 is going to be printed exactly like after what I had here. So if you wanted to go to the next line, be careful that you add \n to your code. Okay, so let's go ahead and continue our problem. We wanted to calculate sum, and we should be careful that we need to include negative numbers as well. So I'm going to use an if-else statement. Let me pause here and tell you guys this, that all these problems that I do, they can have 1,000 different ways to do it. And a good practice for you is to try to do it in other ways. And one good practice is actually try to minimize the number of operation. It teaches you, you're basically teaching yourself that, can I optimize my own code or not? So if you think that, okay, I could write this with this much line that has, for example, 100 operations for the user to get to the answer, can I kind of come up with an algorithm that makes it much easier? In the case that I'm doing, in this question that I'm doing, there are ways that you can do it much faster and easier. So try to work on it this way. This is the only way that you can learn programming. Okay, so go back to the question. The first condition, I'm going to check if n, the variable the user just entered in a step 3, if it's 0. So if it's 0, I'm going to print, I'm not going to do it, I'm just going to say that print to the file that the sum is 0. And I'm going to use else, but not else if. So else if, this time if n is a positive number, which is n greater than 0. Here we're going to calculate the sum. So use a loop to calculate sum. And of course we have to have the same thing for the case that it's negative, and I don't need to have any condition, because if I just say else, and that would be Because if it's not 0 and not bigger than 0 or greater than 0, it means that it's definitely less than 0, so it's a negative number. So to do it for a negative number, I'm going to use for iterator equals to, I can go ahead and define my variable here. The only difference is between defining a variable here in the for loop or defining that as step 1 at the beginning of the program is the lifetime of the variable. So if I define this variable iterator here, after the for loop, this variable doesn't exist in the program. So I'll show you that as well. So the iterator starts from -1. We are in the negative part. And I'm going to continue the code while I is less than or equal to n, because n is a negative number. And I have to decrement iterator at every step. And I'm going to use I minus minus, iterator minus minus. So the body of the for loop, what I'm going to say sum at any step is sum plus iterator. So be careful about something, that we are using sum in the right hand side. It means that for the first time that this loop is being run, you have to have an initial value for sum. So when you declare your sum in the first step, be careful, you need to initialize it. And then I'm going to add so print the result to the file. And also here, when I calculate it, I have to print it to the file. So if you look at it, the algorithm is in my mind, I definitely haven't written it yet, it's just comments here, is that print a different printf statement if it's 0, a different print statement if it's greater than 0, and a different printf statement if it's less than 0. There has to be a way to do it faster and easier. I'm not going to do it. I'm going to let you guys think about it. First, complete this. Try to complete this and see if your code runs, and then try to optimize your code as much as you can. By optimizing, I mean just try to limit the number of operations. For example, you have 3 printfs and you can make it only 1 by just a slight change in the algorithm. Please go ahead and do that. These practices are going to help you become a good programmer. When you're declaring your variable inside the for loop, it means that this variable won't exist after the for loop. So if I going to use iterator here, and I say, for example, iterator plus 1, and I say int I equals to iterator plus 1, there is an error. Although I have declared iterator here, if I look at the error in Visual Studio, it will tell me that identifier iterator is undefined. And the reason is, let me put this on the column here. And the reason is, this variable that we define inside the for loop only exists inside the body of the for loop. Whenever we get out of the closing code bracket, it doesn't leave anymore. But if I go ahead and declare it inside the program, like here, for example, and then I just use it here, all the errors will go away, and this iterator is basically the same one. We will going to use both. Sometimes you don't want your variable to exist in your main function. You just want it to leave inside the for loop, and that's it. But there are also sometimes that you want it to leave because you're using your for loop to count something, and then that I is the number of the things that you counted. So you want it to exist after your for loop, so that it's better to declare it at the beginning of the code. But sometimes no, you don't want it to, and you want it to die with the for loop. It's better to declare it in the for loop. So in practice problem 3, it asks us to write a program that reads an integer n from the keyboard then computes the first n terms in the famous Fibonacci sequence and prints the sequence to an output file. Okay, so we're writing to a file, Fibonacci out.txt. You may assume that the user will input a value such that n is greater than 0. The Fibonacci sequence is defined as, you can see on the screen, it's start with 0 and 1, and then all the terms is adding the previous and the second previous terms to each other. So it's like 0 to 1. Add 0 to 1, it will be 1. So 0, 0, 1, 1, then 2, 3, 5, 8, and it goes on. In this sequence, after the first two numbers, yeah, it's basically saying what I said. The next term is obtained by adding the previous two numbers. That is 0 plus 1, 1 plus 1, 1 plus 2, 2 plus 3. And is asking us to run our program in n equal to 10 to make sure that we are printing the first 10 numbers in the Fibonacci sequence. Without further ado, let's jump to Visual Studio.
So here's my Visual Studio. I'm going to divide this to different tasks, as I always do for different practice problems. So step 1 would be to declare our variables. Step 2 is open file for writing. Step 3 is ask the user to enter number of terms and scan it. Step 4 is print the first part of the output to the file. Step 5 is to print the terms of the Fibonacci sequence to the file. And step 6 is to close the file. The variables I need for this problem are, so I'm going to have a number of terms. This is the one that I'm going to get from the user. And the second one, I'm going to name it previous. And I'm going to initialize it to 1 because if you look at the Fibonacci sequence, it starts with 0 and then 1. So the previous would be, I know that the first two is going to be 0 and 1, so I'm going to initialize those. And then second previous. And I'm going to initialize that to 0. So I'm already knowing that the first two are going to be 0 and 1. And I need another variable, and I'm going to name it next. So I'm going to have a comment for myself here that initialize the sequence 0, 1, and then etc. Okay, so I've defined my variables. I need to define the file pointer as well. So file pointer, and the name I'm going to name it as file output. Okay, so in step 2, I'm going to open the file for writing. So the file output is the return of the function fopen. And in function fopen, I have to provide two arguments. The first argument is the name of the file, which I want to name it Fibonacci out.txt. And the mode that I'm going to open it is W, which is short for write, because we want it to write to this file. So at this step, I'm going to print a message to the user using printf function. The message is, enter the number of terms, positive integers. And I'm going to store it using scanf function with the format identifier %d, and then I'm going to store it to the memory address of the variable number of terms. So at step 4, we wanted to print the first part of the output to the file. I'm going to use the function fprintf. In function fprintf, we'll learn that the first argument is the name of the file pointer, which is variable file output. The second argument in this function is the message that I'm wanting to print out, and it's the number of terms. Term Fibonacci sequence is colon, and definitely instead of %d, I wanted to print the number of terms. I'm going to go to step 6 and close the file. This way, by pressing Ctrl F5 in Visual Studio or just going to the debug menu and start without debugging, we can compile the code. If I enter 5, for example, and then press enter, so the program compiles without any error. If I press enter here, and then I have to go to Solution Explorer, right click here and go to the open folder in Explorer. And as you can see on my Explorer, I'm going to right click on the Fibonacci.txt, open it with Visual Studio, or just drag and drop it into Visual Studio. And as you can see in my Visual Studio, it says the 5 terms Fibonacci sequences, and the rest is empty because we haven't write the code yet. Okay, so I know that up to this point, step 1, step 2, step 3, step 4, and step 6 are working. So let's focus on step 5. So our program is working fine. Now we wanted to print the sequence of the Fibonacci. I'm going to use the for loop to print the terms of the Fibonacci sequence. So for int I equal to 1. Okay, so in the for loop, in the first part of the for loop, I can declare the variable and initialize it at the same time. This is also a valid code in C++. I'm going to run this loop until I is less than number of terms. Then I'm going to increment I at each loop. Okay, so let's focus on the body of the for loop. In the body of the for loop, each time I'm going to use fprintf function to add a sequence of one of the terms to the sequence. In fprintf function, the first argument is always the file pointer. In this case, is file output. The second argument is what you wanted to, the message you wanted to print. In this case, I only wanted to print an integer followed by a space. And the integer I wanted to print here is the second previous. We're going to start from the beginning. The Fibonacci sequence, you know the formula and it was provided in the practice problems, but it's the way that the next term of the Fibonacci is always previous plus second previous. And I'm just going to write that mass in my for loop. So each time I printed the second previous, I'm going to calculate the next variable as well. So the next one is going to be previous plus second previous. When we calculated, so the first term was 0, the second term is 1. If we add them, next would be 1. So now I have 0, 1, and 1. But I have to update the variable second previous and the variable previous for the next loop. So from now on, when we have 3 terms rather than 2 terms, when we have 0, 1, and 1, the previous and second previous are not 0 and 1 anymore. They should be updated. So I'm going to update second previous first. So second previous would be the value of previous. Because if I'm shifting 1, the value that was stored in previous is actually right now the second previous. I have to update previous as well because the value I just calculated for next, for the second loop, for the next loop, that's actually going to be the previous one. So in this case, I assume that each time that my loop would work, it will print the second previous on the screen. What I'm going to do is I'm going to put all these on different lines because I'm going to debug the code and see what is exactly happening here. I'm going to put a breaking point at line 20 and press F5 to go to debug mode. The code is asking me to enter the number of the terms, a positive integer, and I'm going to enter 5. Okay, so as you can see, we're back to the Visual Studio, and on the local window, the value of number of terms is 5, which we just entered. The value of previous is 1 and second previous is 0, which we expect it to be because we initialized it this way. And value of I and next are not, the variable I and next are not initialized yet. If I step over, I would be 1. So it means that we are at the first iteration of this loop. In comparing I to 5, the condition is true, so it will be a step into the body of the for loop. And at line 24, we're going to print the second previous, which is the first term of the Fibonacci sequence to the file. And then we're going to calculate the next, which is going to be previous plus the second previous. So if I step over, next should change, and next is 1, as you can see. So right now, only one term has been printed, but we wanted to update second previous and previous for the next loop. Because now we're shifting one, second previous is going to be previous and previous is going to be next. So if I step over, you see that this transition is being happened. And if we continue running this code, each time the second previous is being printed, it's exactly what it's printing what we want, because we are shifting second previous and previous in the Fibonacci sequence and printing what the user is expected to be printed here. And now I will be changed to 5. And this is the last time that this condition is true. And this is the last time that the fprintf function is going to print the second previous to the screen. Next will be calculated, but that number is not important for us. We don't want to print 8. And second previous will be updated to 5. And previous will be updated to 8 for the next loop. But we know that if we step over and I becomes 6, this for loop is not going to be executed anymore, because if I step over, we'll be jumped to the fclose command and the file will be closed and our code is finished there. So let me do that. Let me finish compiling the code and stop debugging. And if we go back to our file, we would see that the terms, the 5 terms, 0, 1, 1, 2, 5 is being printed correctly. If I go back to the file, compile and run this time without debugging, and enter 10 and press enter. Press any key to close the window. And then if you go back to the file, you would see that the first 10 terms of the Fibonacci sequence is printed to the file, the way the output is being expected.
In your calculus course, you'll learn that the function ln 1 plus x can be approximated by a polynomial of degree n as follows, as you can see the equation on the screen. This is called a power series approximation. Write a program, powerseries.c, to check the accuracy of this formula. So what we basically want to do is similar to what we did in previous practice problems. We calculate the actual value and the approximate value, and then calculate the relative error to see how accurate that was. Your program must prompt the user to enter for x and the degree n of the polynomial to use. Your program should then write the value of x, n, and the approximation, the actual value, and the percent relative error to the output. Power series out.txt. And we have to run our program for x equal to 0.9 and n equal to 40. I'm going to divide this question into different steps as always. And the first step is to declare your variables. The second step is to open the file for writing. Third step is to ask the user to enter n. And the fourth step, I'm going to calculate the approximate value, but using the power series. Fifth step is the actual value, how to calculate the actual value. And when we calculate the actual value and the approximate value in step 6, we can calculate the relative error. And then we can print the output to the file and finally close the file. To declare my variable, I need a file pointer first. And I'm going to name it file output, as always. I'm going to need some float numbers. The variable x, the approx for short for approximate number, and term so I can save each term of the power series on it in it, and actual, and relative error. We need float, sign, iterator, and n, which is basically the number of the terms the user wanted us to calculate for them. Okay, so by now you should know how to open the file for writing, and it's easy for you to ask the user to enter n. I'm going to work on step 4. On step 4, I'm going to initialize the variable sign that I just created with a positive number, 1. I'm going to initialize the variable approx as well to 0. I'm going to create another float here. Let me actually move it to step 1. I'm going to name it x to I, which means x to the power of I. And I'm going to initialize it here as x, because basically this variable holds x to the power of I, which is the iterator. And if the iterator is 1, x to I should be x, basically. That's why I initialize it with x. So we have to initialize x as well, but we read x from the input as the question says. Then I need a for loop to calculate terms and add them together and to find the approximate value. So iterator equals to 1. I'm going to start from 1, and then iterator has to be less than or equal to n. So we continue the loop, and then iterator plus plus means that at each step I'm going to add 1 to my increment. Okay, and the next step is to calculate the term. Each term, the first term, if you look at, is the sign multiplied by x to the power of I, and then divided by, I don't want it to just divide it by the iterator, because iterator is an integer, and if I divide it by an integer, it might return an integer. So to make everything a float number, I'm going to put float inside parentheses before the variable iterator. What this does, what this command does, it turns iterator from an integer to a float number, but it won't affect the iterator after it, because iterator has to stay integer. So iterator is integer, but for only this calculation, this command will turn it into a float number. And then the approximate number would be approximate plus term. I need to update some of the variables for the next run. For example, the variable sign is now has to be negative sign for the next run, because it's either positive 1 or negative 1. So in the next run, it's going to be negative sign. Update x to I, because now that I is 1, x to I was x. But if x to I, because when I is 2, x to I would be x times x. And when it's 3, it would be x times x times x. I can go ahead and use power function here, but I have to include mass library. If I don't want to include mass library, each time I'm going to use the same x to I and multiply it by x. This is a great practice for calculating power using for loop. Look at it. At the second iteration, it will be x to the power of 2, and then we apply another x to it. So in the third iteration, we will already have x to the power of 3. Let's see. Let's give it some dummy numbers and then try to compile our code. So what I'm going to do, I'm going to hard code x equals to 0.9, basically what the question is asking, and n equals to 40. And now I should be able to compile and run the code with debugging. So I'm going to put a breaking point at line 20. And if I press F5 or go to debug menu and click on start debugging, so you would see all the variables in the local window. Let me step over. First, now our iterator is 1, n is 40. Approximate is 0 because we haven't calculated anything yet. The yellow arrow pointing at line 22 means that line 22 has not been executed yet. And let me actually step over. And you see that term is calculated. Term is calculated. Sign was 1. X to power I was 0.089999976 is the way that Visual Studio stores 0.9. It's weird, but yeah, this is the way. And we changed float to an iterator to a float. It was 1. Well, it will be changed to 1.000. And now if I step over, approximate value will be updated, as you can see. And it's exactly what I want, because sign was 1, iterator was 1, and x to I was x, so the approximate value now has to be x, and it is 0.9. Now I'm going to update sign, because in the next term, the sign is negative. And I'm going to update x to the power of I. I want you guys to look at that variable. That's this variable here. Now it's 0.9 times 0.9, and we are at iteration number 1, but we are actually updating our variable for the next iteration. If I step over, now iterator is 2, and 2 is less than 40, which is correct. And then we are jumping to the body of the for loop. In the body of the for loop, we are going to calculate the second term. To calculate the second term, I need the sign for the second term, and x to the power of I for the second term, which we just updated here in the previous term. And definitely I wanted to iterator to be a float number. And again, we're going to update so we can just calculate a term, and then we update the approximate value using the term we just calculated, and we can continue going on in this. And if I press continue, let me actually put a breaking point here and debug the code again, and you will see that the approximate value would be 0.64168, and that's exactly what question is asking us to do. To tell you guys through, I've been saying this a lot, but this is one way of doing this. For step 4, at least, you can write different kinds of code that will have the same output. You can use math library functions like power function, and probably your code would be much smaller than mine. And that's sometimes a good thing and sometimes a bad thing. I would avoid using power function if I can. If it's easy to avoid power function, I would avoid using it because it has its own overhead, and it's not performance-wise, it's not good. Guys, I'm talking about performance. The code that we are writing is not going to take a long time that you care about performance. The only reason I'm telling you guys to just have a look for performance is to learn how to write code better. Because the reason we write code in C and C++ is we wanted to get a performance. We are engineers. We're going to work with big numbers and big matrices in future. We wanted to have a program, have a code that runs as fast as possible. Imagine you're multiplying a matrix that is 1 million by 1 million to another matrix, and this is going to take time. If you optimize your code as much as you can, you'll get to the result fast. So try to learn now by just write as different ways as you can for step 4. In this case, you cannot do much for other steps, but in a step 4, there are at least a couple of other ways that I can think of out of my mind that you can change this code. Not necessarily getting it better, but you're in the practice mode. You just wanted to know what are all the algorithms that I can use to write the code for this problem. Thank you guys for watching this video. If you have any questions, please let us know. We'll be glad to help you guys, and have a great day. And as always, see you in the next video.